Okay, so this is page 13 of your packet. And I just want to say, in practicing the math of this, you never have to convert from milliliters to liters, even though molarity, we have always been taught, is moles per liter of solution. But if you start in milliliters, you're going to end in milliliters. The other thing that I want to show you on this page is that some of the acids and some of the bases are either diprotic or triprotic, and we have to incorporate that in the formula. So here we go with titration. This is a big lesson, and it's really not hard as long as we know how to put the numbers in their proper place. So a sample is 25 milliliter sample of HCl. So that's the volume of the acid. Was titrated to its endpoint with 15 milliliters of a 2 molar sodium hydroxide. So 15 milliliters is the volume of the base, and 2 molar is the concentration of the base, or the molarity of the base. What is the molarity of the acid? So molarity of the acid is the X. This is HCl, so it's monoprotic, it's a 1. This is hydroxide, it's monohydroxy, so it's a 1. So molarity of the acid times the volume of the acid is equal to molarity of the base times the volume of the base. So this would be a 1 and a 1. So molarity of the acid is the unknown. Volume of the acid is 25 milliliters. Molarity of the base is 2 molar. And the volume of the base is 15 milliliters. So there you go. It's just a plug and play. And I'm assuming X equals 1.2. That's what the answer key says. Let's look at number 2. Do you see that this is H3PO4? So that's phosphoric acid. And this is sodium hydroxide, so that's okay. It's just 1 hydroxy. So same formula, molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. But we have to take into consideration the fact that 3 moles of hydrogen ion is released. So we're going to multiply that by 3. So how much 1.5 molar sodium hydroxide? So that's the molarity of the base. How much of it, that's our X, is equal to 20 milliliters of a 2.5. So we have the 2.5 times the 20 times the 3. And then solving for X should get you the 100 milliliters. So I'm just going to check it just to make sure using a calculator. 3 times 2.5 times 20 gave us 150 divided by 1.5 gave us the 100 milliliters back. That's good. So I would recommend that you practice this page and you look for the fact that we are dealing with, if we have a 3 here, then we need a 3 on the acid side. So that would be the molarity of the acid times the volume of the acid times 3. And look what's happening here, dihydroxy. So we have to incorporate that. So molarity of the base times the volume of the base times 2. So this is a very doable, very workable calculation. And we will have posted a titration calculation practice worksheet. If you need anything throughout the week, feel free to reach out on the Google Classroom or on the group chat. Take it easy, everyone. I just want to say, for those of us who are observing the holiday towards the end of this week, have a happy, safe holiday with your family. Make sure you still comply with social distancing so we all stay healthy and safe. Take care.